Hello students, this video is to help you with Unit 2, which is Special Triangles. We're talking about the problem sets from lessons 1 through 3. Those problem sets talk about angles inside of triangles, triangle theorems, and also proofs involving triangles. We're taking a look first at the Lesson 1 problem set. Pause the video, see if you can understand these questions, and then come back to see if you got them right. Alright. For question number 1, it asks what type of triangle is triangle ABC. It gives us 3 angles, which means we're able to use the Triangle Sum Theorem. This Triangle Sum Theorem tells us that the 3 angles added together are equal to 180. So we added them together and did some algebra to them. I'm not going to teach you algebra because you're good at that. That's why you're in geometry. Anyway, x is equal to 18. Once we got x is equal to 18, notice it asks what type of triangle is triangle ABC. We substitute 18 into all of the 3 angles, and we get 55, 55, and 70. Sounds like there are 2 angles that are exactly the same measure, which means it is an isosceles triangle. Isosceles meaning 2 base angles are congruent. If all 3 angles were 60 degrees, then it would be an equilateral triangle. If all 3 angles were different measurements, if this was 50 and this was 60 for argument's sake, that would be scalene. And in order for it to be a right triangle, it would have to have one that is 90 degrees. For question number 2, it asks us to solve for x. Same thing here, we're using the Triangle Sum Theorem. All 3 angles added together equal 180. Set them up and solve x is equal to 74. For number 3, it asks us to find these 2 different angles. Now watch what I did here. I traced out this large triangle with red, traced out this small triangle with green, and I traced out this supplementary angle pair with blue. I tried to color code as much as possible, so this is the red triangle, this is the blue supplementary angles, and this is the green triangles. Take a look at those, see if they make sense to you. For number 4, it gave us some information which we labeled on the diagram, and we also know that this is an exterior angle, so we probably know we're using the exterior angle theorem. This exterior angle theorem says that the 2 interior angles, the 2 remote interior angles, are equal to the exterior angle, so we set them up. We only don't know ACB, but we know this CAB, and we know ABT, we know both of those, so we're able to substitute them into the exterior angle theorem and get our answer. Moving on to the next page in the problem set for lesson 1, pause the video, try these questions, and then come back to see if you got them right. Alright, we use the Triangle Sum Theorem and Supplementary Angles for this question. The first thing we use is Triangle Sum Theorem to try to determine the missing angle here, which is triangle ADB, or BDA, whichever is your pleasure, is 120. Once we know that this is 120, we can use supplementary angles, this blue highlighting, and we know that BDC is equal to 60. We actually did not need the information here. We did not need that angle C is equal to 60 in this problem, but we could have used that to find this angle, which is CBD. For question 6, it asks us to find the measure of angle C. So we use the equilateral triangle theorem first. Since it's an equilateral triangle, all angles are equal to 60. We label those in there. Then we use supplementary angles, this green highlighting 60 and 120 is 180. And then after that, we use the Triangle Sum Theorem, 120 plus x is equal to 180. I color-coded these in purple because I identified that it's an isosceles triangle. The 2 base angles are congruent. Once I know that, 120 plus 30, that's what we got over here, is equal to 180. So the measure of angle C is equal to 30. For question 7, it's an isosceles triangle again. That means that these 2 base angles are congruent. That's why I wrote down the isosceles triangle theorem. The Triangle Sum Theorem tells us that the 3 angles are equal to 180. So x plus 80, these 3 angles are equal to 180. Then we solve for x. Once we solve for x, it did ask us for the angle BCD. It's very important to annotate these problems. Notice how I circled what it's asking us to find so that I know whether I found it or not. Angle BCD is found by substituting values into the Supplementary Angles theorem, which is angle plus angle is equal to 180. I know this angle, angle x, which is 50, so I just needed to find this one, which is 130. Question number 8. It gives us 2 angles on the inside, 2 remote interior angles, and 1 on the outside, an exterior angle. We find out the value of x, and again, we're asked for angle CAB, so we must substitute into angle CAB to find that answer. Moving on to problem set from lesson number 2. This one was a little bit more complicated. Some of these questions involved quadratic equations. Pause the video, try these out, and see if you got them right. All right. We're looking for the value of x here. We're given two remote interior angles and an exterior angle, so we only need to use the exterior angle theorem. Angle plus angle is equal to angle. Keep in mind that these two angles on the left-hand side, these are remote interior angles, and this angle on the right-hand side, that is the exterior angle. It asks us for the value of x, so we found that. We didn't have to substitute it in. If it asked us for the value of angle BCD, we'd have to substitute it in here, but it did not. This question also asks us for the value of x. This problem gives us a quadratic formula. If you remember from class, we call this a quadratic equation because it has an x squared in it. If you remember, the Latin word for square is quadratum. It sounds like the Spanish word, and the Italian word for square. Anyway, it's a quadratic equation, which means we solve it by setting it equal to 0, and then factor it as much as we can. We factor it into x minus 15 and x plus 2. We split it up and solved it. For question number 3, both of these two theorems were needed. First, we used supplementary angles. We were only able to use supplementary angles because we knew 52, and we also know that this angle and this angle were congruent to each other. It says EBD is congruent to CBD. Remember, this symbol, congruent, means same measure. So this is x and this is x. Adding them together to equal 180, we can solve and get x is equal to 64. Once we know that this value is 64, we know the triangle sum theorem takes this purple triangle and says, well, this angle here is 64. This angle's got to be 90 because it's on the other side of a 90-degree angle, and 90 plus 90 is 180. So now we're trying to find angle D, which is, after a couple of steps here, we get angle D is equal to 26 degrees. For question 4, it's asking for angle STR. Again, we're told that RS is congruent to ST. That means that these two sides are congruent, which means it's an isosceles triangle. Isosceles triangles have two base angles that are congruent. Once we know that, we just use the triangle sum theorem. It's the easiest thing in the world. Vertex angle A, when it says vertex angle in an isosceles triangle, the vertex angle is the different one. The other angles that are here and here, for example, these are base angles. The vertex angle is the different one. So here is the vertex angle, here are the two base angles. We solved that by using the triangle sum theorem. This was an algebraic sentence, but you were able to figure that out pretty easily, hopefully. 3 times angle B is 3x. 20 more means plus 20. And we're asked to find measure of angle C, so we found that pretty readily by solving for x. Moving on to the next page. In the problem set for lesson 2, pause the video, try them out, and then see if you got them right. All right, the first question gives us a ratio. You know that a ratio is a relationship between numbers, and this ratio is in simplest form. I don't know what these numbers are in actuality, but I know that in simplest form, the relationship is 5 to 6 to 7. That means in order to find the actual numbers, I can use 5x, 6x, and 7x in our problem in order to show their relationship, because I don't know what x is, but it's the same number for all 3 values in the ratio. I set up the triangle sum theorem, which is all angles equal to 180, and then I solve for x. Once I find the value of x, it did ask us for the smallest angle. In this case, 5x is going to be the smallest angle, because 7 is a bigger number than 5, right? And 6 is a bigger number. Stick with me here. So anyway, it's the smallest angle, which means that 5 times 10 is equal to 50. For question number 7, it gives us more verbal expressions here, 21 less than 4 times the measure of A, etc. Notice that both B and C are in terms of A. In terms of A meaning the measure of A is there somewhere. If the measure of A is written in there, that means this is the thing that we're going to use as the variable. The measure of A is here, and we also have the measure of A here. So that's going to be the variable. So we set the measure of A to be the variable, and then everything else is in terms of A. That's a little algebra trick for you. Draw the triangle, triangle sum theorem, solve for x, and then substitute it in because it asks for each angle of triangle ABC. For question number 8, we draw a triangle again. It's a right triangle, which means it's got a right angle. This is the right angle here. It tells us that angle D is equal to 90. Then it tells us F is 12 degrees less than twice measure of angle E. Again, here's what is in terms of, right? Measure of angle F is in terms of measure of angle E. So that means that is our variable. Triangle sum theorem to find x, and it just so happens that x is the same as angle E. For question 9, we drew a triangle. It says extended. Extended means it's going to have an exterior angle somewhere. So there's our exterior angle. We use our exterior angle theorem. which is interior, remote interior plus remote interior equals exterior. You should know this. This was on your notes. Solve the equation and get x equals 15, and then we're asked to find QPT, which means we substitute it in. In number 10, it gives us the angles, and it also tells us that the measure of angle F is equal to the measure of angle H. That tells us that it is an isosceles triangle. If it's an isosceles triangle, then these two angles are the same. And also, these two sides are the same. Notice that this is talking about sides, not angles. But that's okay, because I know that this side, GF, which is here, is exactly the same measurement as this side. Oh, not this side, but this side, GH. They're the same because it's an isosceles triangle. And I know that if this and this are the same, I can set them equal to each other. That's what I did here. For question number 11, there were a couple of steps, so stick with me here. First, angle bisector. It tells us angle O and angle M are bisected, which means cut in half. That means that if this angle is 56, this angle and this angle have to be 28. The next part says that angle addition postulate takes that 28 and that 28, adds them together, that equals 56. The next part tells us that the triangle sum theorem, which means all three angles are equal to 180, can help us find the measure of angle MON. MON being up here. That is 84. Well, if that angle is 84, it was cut in half before, right? So that means this is 42, this is 42. Then we use the triangle sum theorem to find the measure of angle OST. That measure of OST is equal to 78. And finally, we use the triangle sum theorem one last time on this little orange triangle. I have 42, I have 78. I'm just missing OTS, which is the thing that I was asking for in the first place. For number 12, again, it is several different steps, but you should be able to follow it using the color coding. Pause the video for a moment if you're not really sure what's going on and try to sort through what's going on here. Moving on to the lesson 3 problem set, these were all proofs. Some of the proofs you knew how to do, and some of the proofs we're going to be going over in future lessons. So pause the video, try them out, and then come back to see the correct answers. All right, this first proof asked us about y, v, and z. That is equal to 180. The first step says that angle x is equal to angle y, and I know that these two angles are congruent because of vertical angles. The next step tells us that x, v, and z are equal to 180. Well, x, v, and z are the interior angles, so of course they're equal to 180. Then I can take x and replace it with y because they're the same angle. This is substitution. Next, it asks us to prove this statement, and you should notice that there are two triangles here, a large triangle and a small triangle. We're setting both of them equal to 180 and saying triangle sum theorem for both, but then since they're both equal to 180, they're going to be equal to each other. I'm calling this substitution for now, but later on you'll see another word that is specifically for whole equations being set equal to each other. For right now, let's call it substitution. Then we subtracted a from both sides, and we got this final answer, which is the same as the proof. For question number 4, I color-coded this one as well. We know that in this problem, it says angle CBF, CBF is here, plus BFC, BFC is here, and FCB, FCB is here. Those three angles are equal to 180 because they're interior angles of a triangle. Well, it turns out that this angle and this angle are the same. This angle and this angle are the same. This angle and this angle are the same because of vertical angles. They're all examples of vertical angles. So CBF is the same exact angle as ABJ, so I replaced it with ABJ. That's substitution. I did the same thing for the red angle, and I did the same thing for the blue angle. You should be able to follow that along. All I did was substitution 3 times. Last but not least, take a look at this page. You were able to do the first one, so try that out, and then come back to see if you got it right. All right, this symbol means perpendicular, which means it forms right angles. And I already know that some of the angles are marked for us. For example, this one's 60 and this one's 60. That means this one must be 60, according to the triangle sum theorem. 60 plus 60 plus 60 is 180. I also know that this is 90 and this is 60, so that must be 30. Again, triangle sum theorem. That means that this little green triangle has a 30 and a 60. That means this angle has to be 90, according to, that's right, the triangle sum theorem. Now I know that DGF is a right angle because all right angles are 90 degrees, and DC is perpendicular to EF because perpendicular lines form right angles. These next 2 proofs are examples of proofs that we will see later, so you don't need to know these yet, but you'll see them later. All right, this was the video for the problem sets from Unit 2. Good luck studying.